Hi everyone. Today is day 15 of our challenge and we will start the week 3 with that. The problem for today is to prepare a simple time series datasheet using Jena Climate or stock data for RNN model. So today is going to be a little interesting because we are starting something new. We will start with RNNs, LSTMs, something new that we have not used before or learned before. So let's go and start with the flow. The flow is going to be same. Let me hide it. The flow is going to be same, that we will go and use chat gpt for asking questions uh, and everything. So I'll say, hey, it is day 15. I'm using the same context window that I have been using for all that I've used for all my previous uh, problems. So I'll say, hey, it is day 15 and here is the problem statement. So yes, let's wait for it to generate the response. If we need clarification on anything, we'll ask. Uh, so yes. Okay, so a lot of new things I see today. Okay, so next is the base. We will be building the basic RN model tomorrow for sequence prediction. But today we just have to build the time series dataset. So let's understand first. Let's read it and then I'll see what I need to ask next. So I'll see it. It says that today we will be working on time series data and preparing it for training using RNN, which is recurrent neural network. The Jena Climate dataset or stock data are good example to use because they have temporal structures that RNN can learn well. I'll guide you through setting up these dataset for an RNN using TensorFlow slash Keras. So first is we'll import the database, libraries, inspect and preprocess the dataset, then create a time series window, split the data into training, validation, test data. Okay, we'll normalize the data and then we'll create batches for model training. How about we understand about RNN model tomorrow because we will be building the model tomorrow. How about we just focus on preparing the data? So I'll not go and understand how this model works. Maybe I'll park it for tomorrow. So I'll start with what we need to do in the step one. In step one, we need to import libraries. Mm, so how many libraries we are importing? We are importing NumPy, Pandas, okay, TensorFlows, okay. We are importing model selection from sklearn for train test split. We have used this before, so we know what it is and how and why it is used. Then we will use PyPlot as PLT. So we download the CSV here, read the CSV, display the CSV. Okay, okay, let's start. Let's start this step one directly. I'll say Python d15.py. I'll add it to the Git repository. I'll mention the problem. Problem is that we have to prepare a simple time series dataset for an RNN model. The dataset is this. I can dataset is this. So I can go and get the dataset from this Kaggle's. Okay, this it does not exist, so I'll go and update the text, the link here. So dataset we are using this one. Step number one, let's import the libraries. So I'll import numpy as np, import pandas as pb, import tensorflow as df, and from sklearn dot model selection import train test split, import matplot as plt. That's it. Now we will download the Jena dataset. Load the Jena Jena Climate dataset. So yes, URL is this, and data will use pandas read CSV to read this CSV. Mention the URL. It will be returned as the data frame. So we can simply use the head function and this data.info function to get this information of this data set. Not this, we'll go and run this python day 15. Okay, so the info is that it has two columns, date column and the temp column. Date column is of object type. This is the date column, and the temperature is a floating point type. How many rows does this has? It has 3650 entries, as in three. So it has 3650 rows, and the initial first five values look like this. Okay, cool. Now we know. Let's inspect and pre-process the data. Let's inspect. So for each date from 1981, it shows the temperature. And I'll do this, comment this, and we are going to do what? Step is inspect and pre-process data. Inspect and process the data set. Okay. So first we convert the date column to date time and set it as the index. Okay. We have done this when we have done this a couple of times when we were solving our challenge of understanding machine learning. So if you go there, okay, the Wi-Fi is not working. So if I go there, so here you can see we have done a lot of problems where we had to convert the date time field into a format which the model can understand. So first we had to convert the date time into date column into a date time field, and then set it as the index. So use the panda to date time. So data date will be converted to panda to date time. Mention which folder column we have to convert, date column, and then we will look at the head again. It should be date. I have a typo, and then run it. This is how it looks like. Okay, now we will set this as the index. So data set index, we'll set this column as the index, and we do that in place. Okay, now let me look at. Okay, I have to print it now. data dot info, not head. So this is the index now. We don't have that 0, 1, 2, 3, 4, 5. We have these as the index. For this, we have this temperature. For this index, we have this temperature. Sorted. Once done, we want to plot the temperature over time. Plot the temperature over time to visualize. So we'll say plot figure, but would be the size of the figure. 10 is to 6. Size is 10 is to 6. Then we'll go plot data, we will plot, and the label will be temperature over time. On x side we have date, on y side we have temperature, and the title is daily minimum temperature over time, and we simply show it. Correct. Now let's do what? Run this script. So the temperature increases a little, then decreases, it goes to the minimum, then increases. So I guess this is the summer, then we have winter, summer, winter, summer, winter, summer, winter. Winter is almost constant. This time the winter did not reach that much, um, but around 1982 the summer was at peak. So we can visualize the data. Let me take screenshot. Now we'll come back to step number 3, which is uh, um, to create time series windows. To train RNN model, we need to convert the time series into sequences of input and target pair. Okay, this is usually done by creating a sliding window over the time series data. Okay, so what we need to do, as I've told you that I'm not going to go in the deep today because tomorrow I'll go and read about RNN when we will actually build the data. So today we will just address the prerequisites. One of the prerequisites is that to train a RNN, we need to convert the time series into a sequence of input and target pairs. So the time series data should be converted into input and target pairs. This is usually done by creating a sliding window over the time series data. So how do we do that? We get the create time series data. We create the time series data function. Inside that we take the data, the window size and the target size one. Okay, we create two lists x and y. For I in the range of data, how many data minus the window size, the minus the target plus one. So for example, like this window size, let's say we have, let's say window sizes, we want the set the window size of the time series as the 30 days. So it will be, let me do some maths. It will be, let's say we have 100 columns. 100 minus window size is 300. 30 minus target is 1 plus 1. So we'll have 70. So the range will be from I to 70. So the range will be from 1 to 70. We append the 0 to So the first x will append to 0 I for I0. For I0, let's see if length of data is 100. Okay, and and window size is 30. So for I0 to 70, for so I for now the I is 0. It will append from 0 to 0 plus the window size is 30. 30. Okay, then y will be append the this will be the first 30 values will be appended, first 30 temperature will be appended to this x. Now it will append from I plus 1 window size, it is 31. I is 0, 0 plus 30 is 30, and this will be I plus 30 plus 1 is 31. So 31, 0 plus 30 plus 1 is 31. Okay, so it says for 30 days the target is going to be this 30 to 31. Next value. So, okay, okay. So the value will be. Can you please decode this? I do understand, but I need to understand. So we are creating this will be will have the value of the window size 0 to the window size, and it will have the value from window size that is 30 to 31. Okay, so this function creates time series data, and it is responsible for converting the time series data into a set of sliding window inputs. Okay, and their corresponding targeted outputs. Essentially, it is a way to prepare the data for RNN by creating sequences of input and associated predictions. Let's break down each part of this function. Uh, this function takes raw time series data and return it in a format that is useful for training. So it takes the raw time series data, that is this, and return it in a format that is useful for training an RNN. The goal is to create two pairs, X and Y. Create pairs of X and Y. X is the past observation used as input. Y is the future values to be predicted. Okay. That is why we saw here for 30th 0 to 30 the next future value is 31. Hmm. Next future values. Hmm. Okay, so the past values, the next futures value, this are is going to be this. So we have three arguments: the data, time series data, and we have number of uh, time steps to use for predicting. That is the sliding window size, the number of time steps to predict, the number of time steps to use for predicting the next values. Okay, X is the list that will store the sequence, and Y is the list that will store the future value. Corresponding Y is the list that will store the corresponding target values. So this will be done in how many iterations we need to run. This will be we saw in the case of this will be 70, which is window total length of the data minus window size plus target value. So we'll say total length of the value time series and say how many previous values we want to use as input and how many future values we want to predict. So the target values are the future values. So how many previous value we want to use as input to predict the future values and how many future values. Okay. Plus one ensures that we generate the pair correctly without running out of the data. Okay. In simple terms, we are using the future past values to predict the future values. So this will store the past values for these future values. So at this location, we have the future values as this. Future value will start with the window size that will end here, and how many future values we want is like from the target size we get to know, and this will store. Ah, yes, let's understand with the help of example. Let's say we have the data 1, 2, 3, 4, 5, 6, 7. The window size is 3. That means we want the past three values to predict the next step, which is target size 1. Predict the next day value. The future values are something like that I go and ask from Google what is going to be the temperature for the next 5 days. So that is the future value. So it is in this case is the what is the temperature what is going to be the temperature tomorrow. So target value is 1. It will use past three values to predict that value. So to predict tomorrow's temperature, it will use today's temperature, day before yesterday, and yesterday. So it will do x will be 1, 2, 3, y will be 4, x will be 2, 3, 4, y will be 5, x will be 3, 4, 5, y will be 6, x will be 4, 5, 6, y will be 7. And the iteration will run from I length is 337 minus window is 3, 7 minus 3 is 4, 4 plus 1 5. So 0 to 5. See, 0 to 5 only it ran. So 0 to 5 up to 5, which means 0 to 4 only it will run. So this will be the maximum window size. It will not move. It will terminate. The loop will terminate here. So yes, I understand now that we are calculating for the previous input. We are using the previous input and appending it to this x to predict the y values. So this is the target size. So I do want. Hmm. So we'll do what? Prepare time. Let me minimize it and give a couple of lines so that my the code remains in the center, not at the bottom. So I'll say prepare time series data for RNN. I'll say this is the we'll have x and y. X is the past observation, and y is let's say for five past 5 days to predict the next 4 days. So that is past 5 days is x, next 4 days is y. So I'll create a function create time series data. Here I'll take data. Here I'll take window size. Here I'll take feature values. So I'll use create to list. X will be an empty list. Y will be this. um, why is this? Then iteration from I0 to length of the data minus window in range, that is better. Window size plus future days. Let me note this. Go back to the step number 3. Plus 1 so that we never run out of it. And yes, so x dot append, we start with data I plus I to I plus window size minus future days, not window size, and y will be append I plus window size plus I plus window size plus target, not future days, and this is we are getting yes. Now we simply return and numpy dot array x and numpy dot array y. We will pass the window size 30 days, which is use past 30 days data to predict so I'll say we convert the temperature column into numpy array, so that because that is being used here, convert the temperature temp column to numpy array. So we'll do what? Temperature data will be data temp dot values, and we pass and create the numpy arrays using calling this create function. Pass this temperature data window size. This will create the time series window. Create time series data. So we'll have, now we'll simply print x dot shape and print y dot shape, and let's run it. Let's close that and see, and we have an error at line number 46. Okay, let's pass the default value as 1. Let's rename it. Mhm. And we have again line number 46. Mm, mhm. I'm getting this error. In other words, resulting array has an inhomogeneous shape. This typically happens when the input sequence X target sequence do not have a consistent length across all samples. Okay, let me go back and see if I have made any mistake. I from I to plus window size. Okay, it goes from length of data minus window minus target. Okay, minus. It should be minus. It should now run fast. Fine. Let me close it. And yes, it is running fine now. We have the window size of 30. For this, the window size is 1. Okay. Uh, let's come back and now do what we are done with that. Let's look at the. Uh, let me clear the terminal first. Let me move it a little down and split the data into training and validation and test sets. Okay, we have split the data into training, validation, and test set. The training will take 70% of the data from the data set into training, 20 into validation, and 10 into test sets. So train size is going to be 70. Okay, so we get the train size, validation size. We get the train and okay, then we get the validation and then we get the test. Why did we even import that function? Strange. We why even import if not using in step 4? We are not using. We are doing it. We are doing it by splitting it manually. Why to import it? Right. Let me go and ask this question from ChatGPT. Yes. Yes, let's not do that. Let's use train test split to split the data. Split the data into training will be 70%. Uh, then validation will be 20% and test sets which is going to be 10%. First, we convert the data into training and validation data sets. So we'll do what? First, we'll do what? X train and X temporary, really X validation and test. Then we have y train, y validation and test. So will become train test split pass the x and y. The test size is going to be 0.3, 30%, and the randomness is keep the randomness so that it generates the same output on every run. Now we have this taking 30%, which is the combination of validation and test. So let's split that also. So x validation, x test, y validation, y test will be train test split. Here we mention the x validation test, y validation test, and the test size. Here the test size is going to be 20%, 10%. So test size will be, so this will take 50. According to this is 30%. Now 30% it further divides into 50%, which is going to be 15%. We want to go ahead with 10 and 20%. So it should be 30%. 10% of 30% is okay. So now we want to go ahead with uh, uh, it is going to be 70% and 30%, right? So it should be 30%, not 30%. Just a second. 10% of 30 is 3. 3, right? So it is going to be 0.3. Random state is 42 again. Yes. So the 30%, 10% of 30. So 10% of this is going to be 0.3. It is 20%, 10. So it will take 70%. No, 70% I don't want. No. So we have a 30% data. Now out of that 30%, 100%, 30% will be used for 10%. And yes, correct. Once done, I will minimize that and go back to, so that step is done. We'll go back to step number normal 5, which is normalize the data. What are we doing? So it is a good idea to normalize the data. We have used min max scalar to normalize the data before also, so we are going to use that. So first import it from scalar dot min, from a scalar learn preprocessing, import min max scalar. So normalize the data. So we define scalar min max scalar, mention the feature range will lie between 0 to 1, and so x train will be scalar sort fit transform x train reshape -1 1. Why are we doing that? Reshape x train I'll simply ask, why are we doing? So it reshapes the data into a 2D column suitable for scalar. Okay. Scale the data and then reshape back to the original shape so that it fits the model requirement. Okay. So if we understand it with the help of example, it first reshape into a 2D column so that the scalar can transform it. So suppose we have 1, 2, 3, 4, 5, 6, 7, 8, 9. X chain is 3 by 3, and then it shape becomes, if we want the scale, want to scale all the values between 0 to 1, we need to reshape it to 9 is to 1 first. Why? Okay, so 3 is to 3 into is 9. So how many values it is going to be? Whole 1 to 9. So it will be reshaped into 9 into 1. So we will reshape 9 is in between 9 is to 1, and then we train it. So 2D vector to convert it into 1D is 3 into the 3 9. So it will be, uh, this in 3D vector will turn into 2D vector like this, and that is why reshaping it, and we transform it and then we reshape it back to the original. Okay, we do the same with the X validation. Scalars dot fit transform X validation dot reshape, into a 2D vector, and then reshape again into validation, not shape, so that we can keep do what, train the model, and then we will do the same on x test. We'll do fit transform, and we'll say x test dot reshape -1 1, reshape back to original, test dot shape, come back to the step, we come back to the step number 5. So we have fit the training data, fit the training, validation, and test data. Now targets are also scaled to 0 and 1. So if we use the same vocabulary, x, y train will be scalar dot transform y train, y validation is scalars dot transform y validation, y test scalars dot transform y test. Done. We are done with the step number 5. We'll now come to the last step of today, which is step 6. So we create the batches for RNN model using TensorFlow datasets. So why are we doing that? Let's first understand that. We now need to create batches of time series data that we can feed into RNN model. Okay, so we need to feed data into RNN model in the form of batches. We saw the similar thing in the case of CNN neural networks. We were passing it in the form of batches that we specify at the time of training the model using the fit function. But here we are creating it explicitly. So we create the batches for the training dataset using from tensor slice. We create the So why are we using this? To create dataset from our numpy arrays. Okay. Caching, shuffling, batching, and prefetching are used to speed up the data access and improve training process. So it says we apply caching, shuffling, batching, and prefetching. Caching, shuffling, using that buffer size, batching, and then we apply batching, and then we apply prefetching to improve the training performance. Okay, let's understand that. Can you please explain in short and with example, easy understand examples of why we are doing this? So let's understand why we are doing that. The last step of today's problem. Hmm. Okay, it has generated. So it says that the code is used to create TensorFlow dataset. That is why we are using from TensorFlow slices. So we are creating TensorFlow dataset object that is optimized for efficient learning. Let's understand why we do each step and with simple examples. First, we create the dataset object from the data. So we have the data, the training data, and the target labels into a TensorFlow dataset. Okay, so it converts the training data and target into a TensorFlow dataset. Why do we do that? Each So this takes each sample from the X train and each corresponding label from the Y train and pair them together. Okay, we will do what? I'll print it. It's like make a dataset where each input range is matched with the correct label. Okay, so it creates TensorFlow dataset. We will look at that and see how it is. So, for example, this is the training dataset, and so these are the windows, and this is the target label. So it creates a TensorFlow dataset like this: input label, input label, input label. Okay, then it applies uh, caching. Let's do what? Let's create it one by one. It applies caching. This caches the dataset into memory, which makes it means it stores. Okay, so it stores it in the memory. That is, of course, for the faster access. And then this tensor will store it in the cache, which is, of course, that is in the memory, so that it becomes faster to fetch. Then shuffling makes. Then we shuffle the dataset. We shuffle the dataset using randomly shuffles the dataset. Okay, why we shuffle the dataset? Shuffling makes sure that the model does not learn any unintended patterns that might be present if the data is in the. Okay, so for example, if the data is in the specific order, it might learn an unintended pattern. So for that, we shuffle randomly. Understood. So for example, if the buffer size is 1000, Tensor will randomly pick and mix elements from a buffer of 1000 samples to create a random dataset for each book. Okay, so it is taking a buffer size of 1000, which means it is uh, creating a sample of 100, or creating, so we'll randomly pick and mix the elements from a buffer of 1000 samples. Okay, so it will take 1000 samples and create and mix the elements to create random data sets. Okay, so why are we doing it? We are doing it because suppose if the data is in the specific order, it may present something, present to the model might pick up a pattern because it is placed in a specific order. So for that, to avoid that, we shuffle. And then the last is we batch the size. That is why we were doing it. We divide the data set into batches of the batch size, past batch size. Instead of feeding the model of all the data at a time, we feed batch of samples. This makes training more efficient, helps the model coverage faster. Okay, that is simple example. If we read 5 pages of a book every day, we'll finish it with more enthusiasm than finishing the book, the entire book in 2 days. So that is why we are converting into batches. And then prefetch, the last step. Prefetch is the next step. Why what it does, it prefetches the next batch while the current batch is in the process. Okay, prefetching helps overlap data preparation and model training. While the model is training on one batch, the system is already preparing. Okay, prefetch is that it makes sure that when the data is the model is training one data, it prefetches the next batch, so that next batch is available when the model is done with training on the previous batch. So this keeps the GPU busy all the time and making it faster. Wow. And this means this TF dot data dot auto means that a TensorFlow will decide an optimal number of the batches to prefetch automatically. Okay, so it will decide the optimal number of batches according to the GPU and CPU usage. Optimal number of batches to prefetch automatically. Okay, this is like cooking a meal. We first create the dataset, apply caching because then it becomes easier to fetch, shuffle so that it does not pick up a pattern because of the placing of the samples or order. Then we separate it into batches, and then we prefetch it for so that we make sure that the next batch is prepared while the model is training the current batch. So let's come back here and write the code for this step. Yep. So here the last step is create batches for model training. So we'll do what? Batch size is 32 and buffer size is 1000. So create training tensor flow data set. I have a same typo. Here I mention the train data set will be, let's import the library. It is, let's import the function import tensorflow data. I think there is no function like that. Let's df dot data set from from tensor slides, mention the x train, y train. Train dataset will be TensorFlow dot, sorry, the train dataset apply caching, then apply shuffling, shuffle, mention the buffer size, then apply, after shuffling what we were doing, shuffled batch size, the batch of the batch size, and then we prefetch uh, prefetch using the optimum size. So tensor dot auto tune. Once done, we do the same for our validation and test dataset. Validation, here test, replace every train with the validation. Here we mention x validation, y validation. Here x test, y test. It is going to be test dataset. This will change test dataset, test dataset. So we are done with the step 6 for, so we are done with preparing the data for our RNN model. This is done, I guess, almost done for what we have to do today. We'll come back. First we will understand what this RNN model is, and then we will train the model on the data that we have prepared today. But before that, I want to go and check how this data looks like. So I'll do what, print train dataset. Let's do that. Run the script, close it, and 75 we have an error. Should be like this. Run it again, close it, and okay, so let's do the same. We, the parameters we did not pass nicely as it expected. Let's wait. This is how the data TensorFlow dataset looks like. Shape is of size this and this. So yes, we are done with preparing the data. Let's commit the code and come back tomorrow and continue with building the model, RNN model on this data. Git status, git add t15, git commit, add code for t15. Let's say d15 prepare time c data. Let's push it to d15 to the repository. Here we see the code. So we are done with what we have to do today, and come back and continue.